Hello everyone, and thank you for being here. Today, I'm excited to present MCP Corpus, a large-scale and evolvable dataset designed to analyze the MCP ecosystem. Let's first briefly talk about why MCP matters. As large language models are increasingly integrated with external tools, developers face major challenges in managing inconsistent interfaces and ad hoc connections. That's where Model Context Protocol comes in. It offers a lightweight, standardized interface that defines how tools interact with LLMs. However, with MCP's rapid adoption, we are seeing a growing number of fragmented and loosely implemented MCP services. So naturally, we ask, can we understand this evolving ecosystem in a structured and scalable way? This question motivated the creation of MCP Corpus. Building such a dataset wasn't trivial. The MCP ecosystem is decentralized artifacts are scattered across GitHub repositories, registry websites, and community hubs. Previous studies mostly relied on small samples or single-source observations. To address this, we designed a multi-stage pipeline that aggregates and unifies MCP artifacts. We combine data from MCP and GitHub, applied schema normalization, filtered out invalid entries, and deduplicated overlapping records. The result is MCP Corpus, a consistent and scalable dataset covering more than 14,000 MCP servers and 300 clients. Let me give you a clearer picture of what's inside. Each MCP artifact in the dataset is annotated with up to 26 structured fields, including basic identity, tool configurations, interface type, and GitHub activity signals. We chose the JSON-L format to allow easy parsing, filtering, and downstream integration. By combining the MCP, registry, with GitHub metadata, we created a dataset that is both comprehensive and up-to-date. To help researchers navigate the data more easily, we categorized the attributes into 4 types: basic info, interface configuration, GitHub signals, and metadata. As an example, one of the top projects is Microsoft's Playwright MCP, a browser automation server written in TypeScript. This demonstrates how MCP Corpus links tool interface, code metadata, and usage context in one place. Let's take a step back and look at some broader trends. We analyzed the distribution of GitHub stars. Most MCP artifacts are still early stage, with fewer than 10 stars. This long-tail distribution reflects a fast-growing but still immature ecosystem. We also examined programming language use. Python, TypeScript, and JavaScript dominate, indicating developer preference and tool compatibility. Now that we understand what's in MCP Corpus, how can we use it? There are 2 main directions. First, ecosystem analysis. We can study the evolution of MCP adoption, identify clusters of tools by domain or language, and track maintenance status over time. Second, security auditing. By inspecting exposed endpoints, unsafe configurations, or missing authentication, MCP Corpus enables vulnerability and compliance analysis at scale. MCP Corpus is open source and available on GitHub. We provide utility scripts for updating the dataset, syncing metadata, and exploring artifacts via a lightweight search interface. This makes it easy for researchers and developers to work with the data without worrying about crawling, normalization, or maintenance. To conclude, MCP Corpus fills a crucial gap in the research landscape around MCP. It supports scalable, reproducible analysis of real-world MCP artifacts, enabling research in interoperability, tool integration, and protocol security. We welcome the community to explore, build upon, and contribute to MCP Corpus. Thank you very much.